Hi, in this lesson you're going to learn about radical equations. Now, we've already worked with radicals and hopefully you have some skill with that and feel confident. Remember, equations have two expressions with an equal sign in between them, and the goal is to find values of the variable that make them true. There will be an unknown in the radicand when you have a radical equation. Here's the process to solve. First of all, determine the restrictions. You have to think about what values of the variable are permitted and what aren't. You can't take the square root of a negative. So if a is the representation of the radicand, it has to be greater than or equal to 0. Having determined that, isolate the radical, remove the radical by raising the whole equation to an exponent. For example, square to remove a square root. You have to do this on each side of the equation, as I'll show you. Then you solve for the unknown, now that the radicals are gone, and then finally check that the solution is valid and not extraneous, meaning a root that seems to work but doesn't actually work. All right, here's a fairly simple question. State restrictions and solve. All right, well, on the left side, I see the x minus 1 in a radical, and I know that what I have inside of a radical has to be 0 or more. So this leads me to saying x has to be greater than or equal to 1. Now on the right side, I see that this whole radical is equal to an unknown. Radicals produce positive results. The smallest value could be 0. So the right side as well has to be at least 0. Now this is the more restrictive case, so this is the restriction that we'll use. All right, we've done the first part. Next part, we're going to raise the entire equation to degree 2, or square it, because I have a square root. I do it on the left side and the right side, not term by term. All right, 4, the square of the square root cancel, and x squared over here. This is now a quadratic equation. So I'll solve it by gathering all the terms to one side. I have x squared on the right. There's a 4x that I bring across by subtracting. Over here is minus 4. I bring it across by adding. I'll factor this quadratic, keep the equation, keep the equals 0, please. And we have x minus 2, x minus 2. So the root is x equals 2 twice, sometimes called a double root. You just have 2 of the same value. And checking, 2 is greater than or equal to 1, so it's valid. So valid. There's your solution for this simple problem. Valid. There we go. Let's move on to a more complex one. All right, this problem has 2 radicals in it. So first of all, I look for restrictions. The contents of the first radical can't be negative. That leads to x greater than or equal. 4 comes across as negative. Divide by 3. There's a restriction. Also, 2x minus 4 can't be negative. Bring the 4 across. It's positive. Divide by the 2. So x greater than or equal to 2 is the more restrictive case. This is more restrictive than negative 4/3. So that's what I'm going to pay attention to. Okay. Now, I am going to take the entire left side. There's like a binomial. I'm going to square it. I'm going to square the 2. So this looks like 3x plus 4 squared minus 2 times 3x plus 4 times 2x minus 4, then lastly plus 2x minus 4 squared equals 4. Now, if that confused you, remember that what I'm doing is this. I have a minus b all squared, which we know is a squared minus 2ab plus b squared. I'm using that expansion pattern that we keep seeing. Oh, that's the end of class, apparently. All right, 3x plus 4 minus 2. Now I'm going to multiply out the radical. I have minus 12 plus 8. So that's minus 4x minus 16. And over here I have 2x minus 4 equals 4. I'm going to gather all the values that aren't in a radical anymore, and I'm going to bring them over to the right side of the equation. Okay, so 3x, 2x, negative 5x on the other side. Plus 4 minus 4, those cancel. So I just have plus 4 on the other side, and a minus 2 here. Okay, now I'm going to square this because, again, I have a radical. Okay, the square of a negative is positive. I get 4. The radical, oops, that should have been a square. My bad. The radical goes away because of squaring the square root. Over here I get 25x squared. This is a binomial square. Remember the pattern for this. Alright, I'm going to expand the left side. 4 times 16 is 64. And I'm going to gather all of these terms to one side. 25x squared, take away 24x squared is just x squared. Negative 40, add 16. That's going to be minus 24x. And 16 add 64 is going to be 80. This will also factor. I see a positive product and negative sum, so my values are going to be 20 and 4, leading to x equals 20 and 4. Now I have to check those against my restrictions, and I'll see that 20 and 4 are both more than 2. So that's the solution.